All right, so in this video, we want to sketch this rational function over here. And we have a negative, and this negative is outside this entire fraction. So basically it applies to the entire top. A cubic equation on the top, and we have a quadratic equation on the bottom. The first thing I want to do is I just want to factor this equation. I can factor an x out of the top, and when I factor the x, I can put the negative and x together, because these two kind of combine when you factor anything out, any common factor out. Now I'll be left with x squared minus 2x plus 1. Just keep in mind that I didn't factor out a negative here. The negative was already factored out. I just factored out an x. That's why none of the signs changed over here. The bottom I'll factor as a complex trinomial. So I'll do that on the side over here. 2x squared minus x minus 1. So what multiplies to negative 2 and adds to negative 1? It's just negative 2 and positive 1. I'll do grouping. Left with x minus 1 times 2x plus 1 on the bottom. Now I can factor this equation over here a bit more. So let me factor that. That's just x minus 1 squared. And now I have x minus 1, x minus 1. So I can actually cancel that with the square, and that's going to create a whole. On the top, I have negative x times x minus 1, and on the bottom, I have 2x plus 1. And like I said, the cancellation of the factor is going to create a whole, and the x value of the whole will just be the solution of the bracket that I canceled, which is positive 1. Find the y value of the whole, I'll sub it into this equation. So negative 1 times 0 is 0. 0 divided by 3 is still 0. So the y value of the whole is 0. Next, I'll look at my simplified equation. So my vertical asymptote is just the solution to the denominator, which is x equals negative 1 over 2. It's x squared over x, which means we're going to have an oblique asymptote, so there's no horizontal asymptote. My x-intercept is just my solutions to the top. So I have x equals to 0, then x equals to 1. But the problem is I also have a whole at that same point. So which one takes precedence, the whole or the x-intercept of 1? So what I've learned is the whole takes precedence, which means we don't include the x-intercept of 1 over here. But if you've learned something different, let me know in the comments. I'm not 100% sure about this. When I put the original equation in Desmos, this whole equation over here, there is no hole in the original graph. It actually fills in this point. But when I put the factored version of this equation in Desmos, it puts the whole at 1, 0, and there's no x-intercept. So from Desmos, I'm not 100% sure either, because it gives us two different answers for the original form versus the factored form. So again, if you know anything about this for sure, put in the comments. Let me know. For now, I'm not going to include this x-intercept over here. My y-intercept, just sub in 0 in this equation. If I sub in 0 here, I'll get 0 as well. My y-intercept. So now I want to find my oblique asymptote, and I'm going to do long division. Before I do that, I just want to expand this so it's easy to long divide. So x squared plus x over 2x plus 1. Now I'll do long division to basically find my whole. Negative x squared plus x, 2x plus 1. So negative x squared divided by 2x is just negative 1 over 2x. I'm going to multiply this with this and subtract it over here. This times this is just negative x squared, and this times this is negative 1 over 2x. x minus negative 1 over 2x is just 3 over 2x. Nothing to bring down, so now I just do this divided by this. So 3 over 2x divided by 2x, that's just 3 over 2 divided by 2, which is just 3 over 4. This is plus 3 over 4, and we can multiply this with this. That's just 3 over 2x plus 3 over 4, and then if I do the subtraction, I'm just left with the remainder of negative 3 over 4, which is not super important. It's the top that we want over there, so our oblique asymptote is y equals to this top equation here, which is negative 1 over 2x plus 3 over 4. Now with this information, I can do my sketch. The vertical asymptote is at x equals negative 1 over 2. My oblique asymptote, put my hole first, is at 1 and 0. My x-intercept is at 0 and 0. And so I put these two. I just need my oblique asymptote, which is negative 1 over 2x plus 3 over 4. So that is going to look something like this. Slope is negative half, and y-intercept, that is 3 over 4 right there. So now we want to do a sketch of this. Normally you would test points, like you would test the number slightly higher and lower than this, but we already have 2 points over here. So this part over here is kind of obvious because there's only one real thing it can do on this side without going through the asymptotes. Over here, it can't be going up because it'll hit this asymptote. I mean, technically it's possible in more complicated questions. You should always do your test points. But in this question over here, well, if I did f of negative 0.4 in my calculator, I'll get a large negative number, which means the point is coming from down over here. I'm going to come through this, going to go through this, it's going to hit this point, and then it's just going to hug the oblique asymptote. And then on this side over here, again, because this is a simpler problem, it's not too difficult. I know this is just going to reflect up there. It's going to look the exact obvious. You don't really have to do a test point, but if you did a test point, you do f of negative 0.6, and you would get a large positive value, which indicates on this side of the asymptote, it's up over here. And then, like I said, it's just going to reflect that shape on the other side and just look basically like that. That would be a final sketch of this situation.